What's up, mathletes? So, someone had a question on number 3 here for this last homework assignment. So, what they're looking for is intervals of increase or decrease. So, again, what you want to do is we have this function here, and this function looks like a parabola opening up. So, we just want to see where is the slope negative on this parabola, right? And then where is the slope positive of the tangent lines. So what we do, the process is we first find f prime of x. So we take the derivative of this function, right? So we get 2x minus 14, and what we do with that derivative, and what's always going to be true, is you set it equal to 0, like we did right here. And now we're going to solve. So we add 14 to both sides, and you got 14 equals 2x. Go ahead and divide by 2, and you get x equals 7. So what that 7 gives us is our boundary point, right? So we got our number line, and we have that 7 right there. So we have these two intervals that we're looking at. The left side where x is less than 7, and the right side where x is greater than 7. And all we do now is we plug in values into our derivative function, right? So one value I'm going to plug in is something to the left of 7, which is 0, and then any number to the right of 7. So I'll plug in 8. All right, so I'll let you copy that down. Go ahead and copy that down. All right, and I forgot you could just press pause, so I'll just continue talking. And so we'll plug in f prime of 0 into the function. So we plug this into this function here. And so when we plug in 0 there, we get negative 14. But the only thing we care about is that you get a negative answer. Because when f prime is negative, what that tells us is that on this left-hand side, that our function f of x, the original function, is decreasing, right? And that's what we're looking for. And then we go ahead and plug in that 8. You could have plugged in any point that you wanted, as long as it's to the right of 7. So if we plug in 8, we're going to get 2 times 8, which is 16. 16 minus 14. So we're going to get equals 2, and which is positive. And so that tells us that the original function on this side is increasing. And let's go ahead and draw that original function. And again, it's just going to look at 7 here. 1, 2, 3, 4, 5, 6, 7. Let's just pretend it looks like this. So here's 7. So what we're finding is the graph is, right, the function is getting less steep, less steep, less steep, less steep, less steep, until here it gets a slope of 0, right, that tangent line. And then it starts getting, it starts growing faster and faster and faster. And this is what we have here. So our function is decreasing from negative infinity to 7, and our function is increasing from 7 to infinity. Sorry about that. That's infinity. So that was for question 3. Alright, so someone else had a question on question 5 from homework 3.1. And again, they were looking to see where, find the intervals where this function is increasing and decreasing. Alright, so once again, we know we're going to need the derivative of this function. So when we take the derivative of this function, you're going to multiply the 3 by 1/3. So those will cancel actually. And so that's going to leave you with x squared minus 25, right? Because that 2 is going to disappear. So that 2 is gone. All right, so we have our derivative of the original function. So you have f prime. And what we do is you set f prime equal to 0. And this is going to help us with our boundary points. And so we go ahead and we factor this using the difference of squares. I have a video for that you could check out in case you need help, which is x plus 5, x minus 5. Right, so there's our two boundary points. We're going to end up with negative 5 here. Notice because they're set equal to 0, so you have to subtract 5, subtract 5. So that's why we get negative 5. And then you're going to have x equals positive 5. Because here you're going to add 5 and you get that positive 5. So these are your boundary points. So we have negative 5, positive 5. We have our intervals. And now we just plug in points. So I could plug in negative 6, I could plug in 0, and I could plug in positive 6. And again, we just want to see where a function is positive or negative. That's our goal. And so we're going to plug in negative 6 into the f prime function, right? The derivative function. So I'm going to plug in negative 6. And again, we just care about the sign. You really don't care about the number. So when you have negative 6, right? That's what we're plugging in. Negative 6 squared is 36. 36 minus 25, that gives us a positive answer. So here, this is positive. So what that tells us is that f of x, the original function, is going to be increasing in this interval right here. Now let's see what's happening in the middle interval. So I plug in 0 now into f prime. So I take f prime of 0, which gives me negative 25. Alright, so again, that tells me here f of x, the original function, is decreasing. And now I'll plug in positive 6, and I'm going to get 6 squared, which is 36 minus 25. I get a positive answer. So here, in this interval, f of x is increasing because I got a positive answer. So now I have my ranges. So when I want to talk about when is the graph increasing, well, it's increasing. We see from negative infinity to negative 5. Right? From here, it's increasing, but it's also increasing over here. So let's include from 5 to infinity. Now, where is our function decreasing? Well, we see it decreasing everywhere here in the middle. So we see it decreasing from negative 5 to 5. So again, this is not a lecture. It's just answering some questions that people had in terms of questions 3 and 5. And so I wanted to help you guys out. What you're going to see in the videos that you're going to watch sometime soon is we're going to take this a step further. We're going to look at the concavity. So you're going to learn from the videos what does it mean when we say concavity. But essentially we're going to take one more derivative. So you're going to take the second derivative. So notice from here to here you took the derivative. What's going to happen is we're going to take the derivative again. And we're going to talk about what does that represent. But essentially you're going to be doing all the same work that we just performed here. Alright, so we'll talk about that soon, and hopefully this is helpful. Bye-bye.